All right, so we have something that says here, in a clinical trial of 2018 subjects treated with a certain drug, 26 reported headaches. What I like to do is start writing at this point because there's so many words here. So the treatment group, I had 26 with headaches out of 2018 total. Then it says in a control group that I had 27 with headaches out of 1650. And it wants you to find what's called relative risk. Let's get another color there. So relative risk is simply finding the probability of the treatment group divided by the probability of the control group. Remember how you find probabilities? You take the number, in this case, that had the headaches, divided by the total number in the study, all divided by the number of control with headaches, divided by the number in the study. And you can either plug this in your calculator, or you're going to actually see me put this in Excel. I'm going to show you how to do this in Excel for reusability to get this answer. All right, the second part asks for the odds ratio, where the odds ratio is the probability of the treatment divided by 1 minus the probability of the treatment, all divided by the probability of the control, divided by 1 minus the probability of the control. Okay, so these are just your definitions for your formulas. Well, the probability of the treatment we just found is up here, which is 26 over 2018. So then now this bottom piece would be 1 minus 26 2013. All this divided by 27 over 1650 divided by 1 minus 27 1650. So hopefully you recognize what this denominator is, this 1 minus. This is the probability they didn't have the headache. Okay, this is the probability, this is the probability they had the headache. Well, 1 minus, because all probabilities have to add to 1, would mean they didn't have the headache. All right, I'm going to again show how to put this in Excel, but if you use your calculator, you should get something like that. All right, the reason I use Excel is for reusability. Meaning, what if this problem showed up on my test? Wouldn't it be cool to have an Excel spreadsheet that all I have to do is type numbers in and then I'm done? So what I'm going to do is I'm going to set this up and say, well, this is going to be my treatment. This is going to be my control. All I did was just type these into these cells. These are called cells. You read them by the column and the row. So that's cell A1, that's cell B1. It said those with headaches, there were 26 in the treatment and 27 in the control. There were 2018 total participants in the treatment and 1,650 in the control. All right, so now down here, I'm going to find the probability of the treatment and the probability of the control. So far all you've seen me do is just type in values. In Excel, when you want it to do the work for you, the calculations, always, 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 always start with an equal sign. Now, what I want to do here is I want to take 26 divided by 2018. However, I don't want to write it that way. The reason why is if these numbers change, I just want to reference these cells. You can do this by either typing, that's A2, or you can just click on it, divided by, click on A3. So this is how I found the probability right here, the 26 over 2018. I'm just simply, let's leave that where we can kind of see it, I'm just simply having Excel do it for me. So when I press enter, Excel did the calculation. The reason you want to do that again, what if you made a mistake and, oh, that should have been 24. When I hit enter, watch this number right here. It changed. So in other words, it updates, and so if you get this problem again, guess what? All you're going to have to do is change these numbers, and your Excel spreadsheet's going to update for you. Let's do the probability of control equal 27 divided by 1650. I did that by clicking on the actual cells, so B2 divided by B3. That's saying what's in cell B2 divided by what's in cell B3. I press enter. I want to find my risk. How do you find risk? You take the probability of treatment divided by the probability of control. So equals probability of treatment divided by probability of control. And I press enter. And remember I said you should get something like 0.787 to round it to 3 decimal places. All right, now the second part, which is the odds ratio, I need the 1 minus the probability of treatment, and I need the 1 minus the probability of control, because remember that's what we use down here. So again, have Excel do it for you. Equals 1 minus, click on that cell, because I want to reference that value. I press enter, and you can see that's 1 minus that value, equals 1 minus the control. So now I have everything I need, so I can simply set this up now to find the odds ratio. I do that by equal the top up here. This entire top is going to be the probability of treatment divided by 1 minus the probability. I want to make sure Excel knows this is all this whole top denominator. So I'm going to do that with parentheses. Open parentheses, probability of treatment divided by 1 minus probability of treatment, close parentheses. That's this entire top up here. Now this line, I need a division. I'm going to put the bottom in parentheses as well, which is the probability of control divided by 1 minus the probability of control, and I need to close my parentheses. So just convince yourself that this is the same formula I have written here. When I press enter, I get my 0.785, which it'll be rounded. So these end up, I can use a fill tool here, these end up being my answers. So okay, now you go take a test, and let's say on the test your problem changed, and it says, oh, well, no, we really said there's 22 now and 2007 4. In the control, there's 20 and 1656. Do you see what happened? This just automatically updated. I mean, I'm done. And so that's what's kind of neat about using Excel is you can save this worksheet now. You can name it Risk and Odds and be able to work these problems very, very quickly. Now, I will mention that I have seen times that rounding, what they actually did in my math lab is they rounded each one of these values. So in other words, instead of 0.010607522, they rounded this to 0.011, which might make these off a little bit. I don't care. If you're off a little bit by a decimal, say this answer here, they actually wanted 0.877. Shoot me an email and tell me I did it just like you did. I was off by, 10, hundreds, thousand, a thousandth of a place, and I'll give you credit for it. It's just the quirks of the lab. How sometimes it's difficult to figure out how they want you to round it.